This is truly a mind-blowing 3D tour of Wolf Branch Sink, which explores from above and below ground in stunning detail. The Apple Maps preview shows the location of Wolf Sink in the Mount Dora area of Lake County, Florida. This karst feature is called a swallet, which is an opening into which a stream, Wolf Branch in this case, disappears underground. Another video at our YouTube site goes through a discussion of the 5 square mile drainage area which comes to Wolf Sink. This aerial map shows the location of the feature and the surrounding residential areas, including Sullivan Ranch. The Mid-Florida Materials Construction and Demolition Debris Landfill is immediately to the west side of the sink. The Old Railroad Grade and State Road 46 are approximate to the site. Prepare for an unparalleled look at the Wolf Branch Sink Complex in Lake County, Florida, with this interactive 3D visualization. This isn't just a map. It's a fully immersive experience, letting you explore the terrain from above and dive below ground to look up at the geological features in breathtaking detail. Created in Google Colab using Python, this visualization is built from a USGS 1-meter digital elevation model and processed with Plotly 3D for an ultra-smooth, high-resolution experience. The elevation data is enhanced with Turbo and YlGn color maps, and point thinning at higher elevations ensures seamless rendering without losing detail. This is a must-see for anyone interested in sinkholes, hydrology, and geospatial analysis. The views are from above ground, cross-sectional views, and the views from under the ground, which are the most incisive way to view these complex karst features. This animation continues and looks at all angles of the stunning shape of these karst features, which are not discernible from the ground or from map, but only with a 3D terrain exploration. Want to explore it yourself? The full interactive HTML version is available from Lake County Engineering Department. This view of the 3-dimensional terrain model goes under the ground and looks upward at the features, which now gives the viewer a more incisive perspective of the shape of the land and the incision of these features into the terrain. Looking at Wolf Sink and its waterfall from below provides a visual appreciation of the features and their uniqueness, and also allows the engineer to see the spinal flow channels within this subtly shaped environment. With 3-dimensional data and the computing power to map it, we now can see Wolf Sink in living color. Now, we can come back to the top and have a different perspective. We hope this 3D interactive model gives the public a better understanding of their karst environment and the spectacular features which remain hidden. The U.S. Geological Survey 1996 publication, Hydrology of the Wolf Branch Sinkhole Basin, Lake County, East Central Florida, is Open File Report 96-143, which was prepared in cooperation with the Lake County Water Authority. A 4-year study of the hydrology of the Wolf Branch Sinkhole Basin in Lake County, Florida, was conducted from 1991 to 95 by the U.S. Geological Survey to provide information about the hydrologic characteristics of the drainage basin in the vicinity of Wolf Sink. Wolf Branch drains a 4.94 square mile area and directly recharges the Upper Floridan Aquifer through Wolf Sink. Because of the direct connection of the sinkhole with the aquifer, a contaminant spill in the basin could pose a threat to the aquifer. The basin morphology is characterized by karst terrain, with many closed depressions which provide surface water storage. Wetlands in the lower third of the basin, south of State Road 46, also provide surface water storage. The conductance of Wolf Sink, the rate at which the sink conducts water to the underlying aquifer, was estimated to be 1.48 cubic feet per second per foot of head difference. In the Wolf Branch Basin, a highly weathered limestone layer at the base of the Hawthorne Formation rests on and is hydraulically connected to the underlying Ocala limestone. The Hawthorne Formation in much of the basin is breached or absent, which has allowed the formation of solution and collapse features common to karst terrain. These karst-related features also allow water to move from the surface to the groundwater through more direct conduits than would normally occur if the hawthorn were intact. The highly weathered limestone at the base of the Hawthorn Formation is transmissive enough to provide domestic water supply in the Wolf Branch area. The Floridan aquifer system consists of limestone and dolomitic limestone of the Ocala limestone, the Avon Park limestone, and the Lake City limestone, and is the primary source of drinking water for Lake County. Attempts to drill an observation well northeast of Wolf Sink, adjacent to an area of surface collapse features, just east of Wolf Branch and south of the railway, were abandoned because drilling 200 ft below land surface failed to reach limestone. A second attempt to drill an observation well adjacent to Wolf Sink, about 100 ft east of the sinkhole, was abandoned after breaching the roof of a large cavity apparently in the clay confining bed about 20 feet below land surface. Wolf Branch is in a recharge area to the Floridan aquifer system. The prevailing direction of regional groundwater flow in the Wolf Branch Basin generally is from west to east, or west to east-northeast. However, groundwater flow paths can be locally affected by the geology of the basin and by the presence of fractures. For example, Wolf Sink acts as a point of recharge to the aquifer and affects the nearby groundwater flow paths. Mounding of the potentiometric surface creates a localized area where flow is moving radially outward, away from the focused point of recharge. Because of this concentrated point of recharge, groundwater near, the sink may be moving in a direction which is opposite the prevailing regional groundwater flow direction. Many of the wells in the Wolf Branch Basin are completed into the limestones of the lower Hawthorn Formation and do not penetrate the Ocala limestone. The Wolf Branch Basin is riddled with depressions, typical of karstic terrain, and there are likely many breaches through the confining materials of the Hawthorn Formation through which water from the land surface can travel through surficial materials and leach through to the limestones of the lower Hawthorn. South of Wolf Branch Road, the stream has a well-defined channel and winds through a heavily wooded area, then through pasture land until just north of SR 46, where the stream broadens into a marsh. Several culverts conduct flow from north to south beneath SR 46, but the principal conveyance structure is a set of 3 36-inch reinforced concrete pipes. Approximately 200 feet east of the sinkhole, the stream bed drops off sharply from an elevation of about 64 feet above sea level to an elevation of about 54 feet above sea level, creating a small waterfall. From the low point at the base of this waterfall, the channel continues westward to the sink. The channel from the waterfall to the sink is ravine-like, with a width of only about 4 feet and steep side slopes rising 20 to 30 feet above the stream bottom. The throat of the sink is filled with sand, debris, and leaves, but the debris does not appear to impede the movement of water through the sink.